Hi everyone, welcome to the video. Today we are going to solve strictly increasing array. In this question we are given an array nums of length n and we have to return minimum number of operations required to modify the array such that this given array may or may not be in the strictly increasing order, in the ascending order. It may or may not be. So or we can say a part of the array can also be in ascending order. So we have to return the number of operations which we will apply to make the entire array in ascending order, or you can say in strictly increasing order. So which means the previous number should be less than the current number, and the current number should be smaller than less than the successive number. Okay, for all the array elements. So using operations it can become negative also. It does not matter. So see in the example 1, 2, 3, 6, 5, and 4. See the first three elements 1, 2, 3 are already in ascending order. But the fourth element, which is 6, index number 3, is not in ascending order. Okay. So what we can do is we'll take a look of it. We'll take a look of it. Okay, this is one such element. What we have to do, it does not, we don't care what we have to do. We'll take a note of it that this element is not in order. Then next element 5. Okay, what if the index number 3 should have been 4 instead of 6? Then index number of 4 is 5. Then it would have been entirely increasing order in ascending order. Okay, 1, 2, 3, 4, and 5. And similarly, if the last index 5 or the sixth element should be 6, in that case the entire array will be in the ascending order, in the strictly increasing order. So we need to modify two elements. Okay, and how we will do it, let's see. So first of all, we are not given length of the array, so we'll store a length of the array nums. Then along with the result variable I will initialize it with 1. So result will store the maximum length of the abnormalities. Abnormalities is what stopping from the array to from being correct, strictly increasing order, number of variations. So the maximum number of variation will be this result variable. Then again I will use dp, initialize it with 1 of length n. Cool. Now I will traverse to the entire array where I starts from 1 to n and j starts from 0 to I. J starts from 0 to I. Cool. Now only one condition wherein we are checking two things. First of all, if the nums I is greater than nums j, which means we are following the successively increasing order or not. If we are, well and good. Then again, if I minus j is less than the difference between nums I and nums j, nums I and nums j less than or equal to the nums I and nums j. If that is the case, which means we are currently standing on a strictly increasing order. We are currently standing on a strictly increasing order. Cool. So at the end, we'll just modify the DPI. The DPI will store the maximum length of strictly increasing order, strictly increasing order till current index, which can be either DPI, the current value, or the value which we calculated, DPJ plus 1. Okay, new value. At the end, at the end, we will again change our value, which will be either res or the DPI, because DPI stores the length of strictly increasing order till current position. Strictly increasing or array length of strictly increasing array up till current index. Cool. At the end, we'll return the total length minus strictly increasing order. Total length minus strictly increasing order. So let's say in example 4, the strictly increasing order was strictly increasing subsequence was of length 4, 1, 2, 3, and 5, and the invariations was 6 and 5, which is 2. Okay, so total length 6 minus strictly increasing subsequence 4, 6 minus 4 will give us 2, and that will be our answer. In example 2, you can see strictly increasing order. No, it's only one element. The first element is in the order. Other three elements are the same, but they should have been increasing order. In that case, it does not matter what we are doing. What only matters is that we have to return the number of invariations. How? We return the difference between the total length of the array minus the strictly increasing subsequence length. We submit and check the efficacy of a solution. So as you can see, it is able to do the job. Okay, okay. So it did the job, but let me try once more. So I used set recursion limit up to 10 raised to the power 8, and I will submit it again to check the efficacy. This will perhaps increase our efficacy. Yeah, this time it took somewhat less time than earlier. So I hope you enjoyed it. Thank you. Have a very nice day.